So, good evening, ADAS. Good evening. It's nice to be here again. So this is the first of two short talks, and this one is, as you can see, a rough guide to buying your first astronomical telescope. For those of you who already have one, perhaps this is a way of reminding yourself how you might reply if you get the perennial question, which telescope should I buy? So it might be for you, it might be for other people. Hopefully there's some useful information in here for all of you. So I'll be giving a little bit of an introduction to buying your first telescope, saying a little bit about types of telescope, the types of mounts that they can be mounted on, and a little bit of pros and cons of the different types to help you gauge which one might be the best telescope for you. And then I'll give you a guide to prices. I've tried to trawl through lots of internet sites and magazines to get a good feel for what sort of price you can expect to pay for different types of telescopes with different apertures, to give you a guide as to whether you're looking at a telescope with a sensible price tag or whether you're being ripped off. And then I'll finish with simply a few sort of personal hints and tips as to what to think about before handing over any of your hard-earned cash. The first question most people get is, what's the best telescope for my X-year-old niece, nephew, son, daughter, granddaughter, grandson, etc.? And it's sometimes a bit difficult to know exactly where to start. You could say, well, the best telescope is clearly one like that. Or you could say to yourself, well, clearly you want to steer clear of something like that. But you could argue that even a small telescope, this one is very limited aperture and very limited focal length, but it's actually fun for kids, and so at of order 50 quid or so, it might actually be a great starting point if you're trying to get a youngster interested or trying to keep the interest of a youngster before they're perhaps old enough to graduate onto what you might think of as a real telescope. That's a little bit unfair because that is a real telescope. It's just on the simplest mounting that you can actually imagine. And it's only 76 millimeters diameter, so you're not expecting to see much. But if all they want to do is to see nice close-up images of the moon, this might be a good place to start. But assuming we're not knee-high to a grasshopper and we're still interested in buying a telescope, where should we start? Well, there are lots of guides that are out there. There are plenty on the internet. The catch is knowing which ones are worth reading, etc. There are lots of guides that are well worth a read, but do bear in mind that beginners' guides that are actually sponsored, for instance this one, sponsored by Celestron, nothing wrong with that, but when you read this particular guide, you will not hear about any other telescopes other than the telescopes of that particular manufacturer. So this particular one, I have no affiliation to Celestron. I do not own a Celestron, but I think this particular guide is actually quite a good one. The only downside is it doesn't tell you about any other telescopes. But I think it's a very good place to start to give yourself an idea of what sort of things you ought to be looking out for. So for instance, I know you can't read this, so that's fine. It's basically answering some of the most common questions that people ask before they actually start shelling out on a telescope. What you can do with telescopes, why there are different types of telescopes, what is going on in a refractor, what is going on in a reflector, why you might pay more money for more expensive telescopes, the different ways telescopes can be mounted, and a little bit about accessories, and it also includes the why you might think about starting, for instance, with binoculars rather than with a small telescope. So these guides are very useful, and they are great places to start. If you read one of these guides and think, right, I've now got a sort of an idea of what telescopes are out there, why one telescope might be perhaps a little better than another, then all I need do now is go to either the internet or get, in the old-fashioned sense, a hard copy of a telescope catalogue, and then I just need to flick through and find the telescope which suits my purpose and my price bracket. But for instance, I've taken this particular one. Again, I have no association with this particular catalogue. I just think it's an interesting one because it contains shed loads of information. But that can be a little bit of an issue because I've tried to just show you what some of the pages look like rather than pass this around. If you open this up and have a look, here's the first 6 pages of the catalogue. You might say, okay, this is interesting. There's the blue telescope, this little rocket or penguin, whatever it is, this little kid's telescope. And there's others. Okay, they're different colors. Maybe that matters, maybe it doesn't. But there's a few telescopes, and I can probably make a decision based on that. But that's only the first 6 pages. If you keep thumbing through this catalogue, you realize there's lots more telescopes. And then you keep thumbing, and there's even more telescopes. And you keep thumbing, and there's even more telescopes. And now we seem to be on a different type. But now we're going to, okay, and there's even more telescopes. And you turn the page, and there's even more telescopes. And this particular catalogue is about 75 pages, most of which is telescopes and accessories and mounts. And you can see that each page might have 2 or 3 or 4 or 5 different telescopes. And it's not long before you think, how on earth am I supposed to tell the difference between these two? Do I have to read every little bit of specification to figure out why that one appears to be twice as expensive as that one, etc.? So it's not surprising that it gets very confusing, even before you get onto how to mount the telescope and how to keep it steady, and even before you get onto different drives and different accessories and filters and eyepieces. Okay, 75 pages that are packed very densely with information. So in a sense, that's great, but of course, it's going to be very confusing unless you've already got a reasonable grasp of what it is you're looking for and the pros and cons of different telescopes. So let's just briefly have a reminder, with apologies for those of you who already know this sort of stuff backwards. But we can classify telescopes, and very, very roughly, there are 4 types of telescopes. Those that use glass to help refract the light and bend the light and focus the light. Nobody uses this word, but strictly speaking, they're called dioptric. It means an instrument which uses glass to focus the light. Some telescopes are so-called catoptrics. Nobody uses this word, but that's the correct word for telescopes that use mirrors rather than glass to focus the light. And you see that these 2 circles overlap because the 2 telescopes in the middle are 2 types of telescope that use some glass and some mirrors. And hence, these particular telescopes in the middle there go under the rather tongue-twisting name of catadioptric, simply because they are the combination of dioptric using lenses and catoptric using mirrors. And if you put those together, you get catadioptric. A real mouthful, lots of syllables, but that's where the word comes from. Nobody actually uses those labels because that's far too confusing, and it's technically correct, but really awkward. So people simply say that when we're dealing with glass, we're talking about refractors. When we're talking about mirrors, we're talking about reflectors. What about these in the middle, which are sort of neither because they have lenses and mirrors? Well, the catadioptric name still survives, and people simply call them cats. Sometimes they're referred to by the particular optical design, but if you hear the word cat, I've got a cat, they mean this in the context of telescope types. So let's just remind ourselves what the physical differences are. If we have a refractor, then we have an objective lens at the front and an eyepiece at the back end. It really doesn't matter whether there's a 45-degree kink in the light travel there. That's just for comfort. It's got nothing to do with the optics per se. And the light will be focused by the lens to a focus, which is then observed with the eyepiece. If you were interested in astrophotography, you might want to put a camera where the lens comes to a focus. Generally speaking, any telescope that you're likely to grab hold of will not have a single piece of glass at the front to focus the light, because any light going through a lens, just like light going through a prism, the colors, different colors will come to a different focus. Just like you know that white light going through a prism gets spread into the spectrum, well, a single piece of glass will do the same, which means red comes to a focus at one point and green comes to a slightly different focus, etc. And if you try and focus on a bright object, you will see color fringing. So to try and mitigate that, basically people design telescopes with different chunks of glass, different shaped glass with different density, to try and deal with the fact that light traveling through glass will always produce some color fringing. Generally speaking, the more money you're prepared to pay, the less color fringing you will notice in your telescope. That's a very, very rough rule of thumb. So multiple lens elements, perhaps 2, perhaps 3, perhaps more than 3, and the more you have, the more you can correct this aberration of having color fringing. But alternatively, don't use lenses at all. If you want to focus light without worrying about color fringing, use a mirror instead. And so we can have a mirror that brings light to a focus, but of course if we wanted to put the eyepiece here and then bring our head up to the eyepiece, we would block the incoming light. So Newton figured out quite a few hundred years ago, one option is to put a flat mirror and intercept the focus and send the light out the side of the tube, and that's the classic Newtonian design, a cylinder with an eyepiece at the top end, because the light has hit the mirror at the bottom, come up to the top, the flat mirror has sent it sideways, and then we place the eyepiece on the side. From this point on, I won't bother showing the eyepiece. So the eyepiece is there just to give you context. In the next few diagrams, I just haven't bothered putting the eyepiece in. An alternative way of using a mirror is to bring the light to a focus from the distant source, and instead of having a flat sending it sideways, an alternative is to use a curved mirror and send the light back down the tube again, which is why there's a hole in the main mirror so that light comes out the back. This so-called Cassegrain design, named after the person who first proposed it, is used in quite a number of different telescopes. The Cassegrain design is basically what's used in the Hubble Space Telescope. One of its principal advantages is you get this impression of the folded light path. That means you can end up with a very long focal length, which means nice high magnification if that's what you're looking for, in a relatively physically short compact tube. For instance, the length of the Hubble Space Telescope is only about 5 meters or so. The distance from the main mirror to this secondary mirror is only about 5 meters. This spacecraft is a bit longer, but remember, the Hubble Space Telescope is actually a spacecraft with a telescope inside it. The telescope doesn't occupy the entire spacecraft. Most of the back end is instruments, most of the front end is a sort of sun shield. So the physical length of the Hubble Space Telescope is only about 5 meters, but its focal length, the effective length, is more than 50 meters, 10 times longer, because of this idea of folding the light in this Cassegrain design. One variant of the Cassegrain design, as you can see, with another name attached to it, a so-called Schmidt-Cassegrain, the idea is using the same sort of thing, but using a mirror that's cheaper to make. I'm not going to go into the details, but previously we had a mirror that focuses light from infinity, called a parabola or paraboloid mirror. It's cheaper to make a spherical mirror the shape of a circle or the shape of a sphere. But that doesn't quite focus light correctly, so although it's cheaper to make that mirror, the light has to be corrected, otherwise you don't get nice pin-sharp stars. So a glass plate is put at the front, a so-called corrector plate, which corrects for the fact that the mirror doesn't focus light perfectly by itself. It's only a thin piece of glass. It looks like it's parallel on both sides. It isn't quite. It's usually flat on the front and very slightly curved on the back surface. And that's what a Schmidt-Cassegrain telescope looks like. Characteristically, you see a glass plate at the front that looks like it's just plain glass. That's how you can recognize a Schmidt-Cassegrain. Just like the previous telescope, it has the advantage, long focal length in a relatively short tube. Another variant on the Cassegrain, so I suppose it really ought to be called the Maksutov Cassegrain. It's another version of the Cassegrain. Again, light is reflected from the main mirror, and then the secondary mirror isn't bolted onto a piece of glass. Basically, a meniscus, a curved piece of glass, is placed at the front, and the mirror is effectively painted onto the back of that particular piece of glass. So it's a different way of constructing to give you, roughly speaking, the same effect. But you can see the characteristic is the front piece of glass, when you look at it, is concave. You can see that it goes inwards. So you can recognize this particular design, the Maksutov design, simply by looking at what is the front piece of glass. Is it flat, is it bowing outwards, or is it bowing inwards? So you can easily recognize these different types. So we said that there's the basic set of telescope types that we might be interested in, but of course we've got to put them on something, we've got to mount them. And the simplest type of mounting is the so-called altazimuth mount, whereby you can move in altitude up and down and in azimuth left and right. And the simplest type of mounting is just something that is virtually do-it-yourself. You can see that it doesn't take a huge amount of engineering, a little bit of plywood and a bit of ingenuity. You can build an altaz mount for yourself. and some of the cheaper telescopes might come on an ALTAS mount. Some ALTAS mounts are motorized, so the motors are built into the actual function of the mount itself. And basically, if you wish, they can be computerized, they can be go-to, they can interact with your smartphone, for instance. But generally speaking, the more functionality you want in the mount, the more you have to pay. The simplest thing is just a mount that holds the telescope and you move the telescope around. If you want motors, if you want computers, if you want go-to facilities, the price goes up and up and up. And so it's up to you to decide where that balance is. But as well as ALTAS, there's another alternative. Why would we choose to have a mount in which the axes of movement of the telescope are at such jaunty angles compared to the fairly simple left, right, up, down? Why would you want to do anything other than that? Well, if you think about the rotation of the Earth rotates with its axis pointing towards the north celestial pole, and as seen from above, the Earth is spinning anti-clockwise, which means if we are somewhere in mid-latitudes, for instance, if we made sure that the mount of our telescope was lined up with one of its axes in the same direction as the rotation of the Earth, that means as the Earth moved and the stars appear to move, we would only need to drive that mount on one axis in order to follow the stars. Whereas in an ALTAS situation, as the stars rise and then go south and then set, we would need to change the azimuth and change the altitude as the stars moved across the sky. With this so-called equatorial system, if we line up one of the axes with the Earth's axis, then we only need to drive one, so it becomes, in principle, a simpler way of doing it. Everybody sooner or later asks about astrophotography. That's not really what this talk is all about, but just for completeness, let me just say that if you do end up buying a telescope, then in principle, a small eyepiece camera, a camera that's effectively the same size as an eyepiece, can replace the eyepiece, and that will work on essentially any telescope you choose to buy. If you've got a telescope with long enough focal lengths, which means relatively high magnification, then you can get good images of the moon and the brighter planets. You can start imaging Saturn and Jupiter, for instance. If you're interested in fainter objects, deep sky objects, nebulae and star clusters and galaxies, that's a little different, because then you'll have to think about long exposures rather than the short exposures you can get with the bright moon and the bright planets. And as soon as you talk about long exposures, then you basically have to think about a good equatorial mount, because you will need to be able to follow the stars for at least many seconds, probably many minutes, and sometimes many hours, in order to get the best out of your astrophotography. So astrophotography might dictate the sort of mount that you need to be thinking about. Some people use whatever they have. Some serious astrophotographers will either buy a dedicated astro camera or will use whatever camera they have. If they already have a bridge camera or a digital SLR camera or a mirrorless camera, they may choose to use those for astrophotography. That's my personal choice. I've already got a digital SLR which I use for taking pictures of animals, so I use that for astrophotography. But one thing you do have to bear in mind with astrophotography, I've put there a little caveat that I'm not going to go into any more detail about the pros and cons of cameras, because that's not what this short talk is all about. That's going to be another day, perhaps. Yeah. So, one thing to bear in mind for those interested in astrophotography, you do not need a telescope to do interesting astrophotography. For instance, here's astrophotography with a digital SLR camera. You don't need a telescope, you just need some way, ideally, of allowing the camera to follow the stars. So you need a tracker. A tracker is something you can build for yourself. I've got a handout here of how you can build yourself a do-it-yourself tracker, and I can give you more details about this. These were all taken with a camera on a tracker, not through a telescope. And you can still take interesting pictures of nebulae and star clusters and galaxies and supernova remnants and the Milky Way, etc. Okay, you've got to get away from light pollution if you want to get the best images, but you do not need a telescope. So, as I say, separate this, do I need a telescope, from I'm interested in astrophotography. If you really do want to buy a telescope and use that telescope for astrophotography, well, fine, that can be very rewarding, but it will take time, it will take effort, and it will take cash. Okay, just remember that when you start the journey of astrophotography. You will need very deep pockets if you want to take it to its limit. So let's have a think about pros and cons. There's basically some of the telescopes we've been talking about, refractors, Newtonians. A Newtonian on the cheapest of ADAS mounts is usually simply called a Dobsonian. That's just the name we give it. There's Maksutov in the top left and Schmidt-Cassegrain in the bottom left. So let's just think about what possible pros and cons apply to these. I've already said that refractors, where the principal objective is a lens that focuses the light rather than a mirror, there will always be some color fringing. The more you pay, the less aberration, the less color fringing you can expect. But basically, there will always be some chromatic aberration. If you go for a telescope which uses mirrors, then you don't have to worry about that, in the sense that the mirror does not produce any color fringing. I've just said a moment ago that a Dobsonian is simply the name we give to this particular style of telescope, the Newtonian, rather than on an equatorial mount. If we put it on the cheapest of ADAS mounts, then that's simply what Dobson did in the some decades ago, and so we just give it that name. I said earlier that the particular design of starting with a Cassegrain, whether it's a Schmidt-Cassegrain or whether it's a Maksutov Cassegrain, we are effectively taking a relatively long focal length and folding it so that it fits into a small tube. So the advantage of these two on the left is you get a lot of focal length for a physically small telescope. On the right there and the Schmidt on the bottom left tend to be relatively large aperture telescopes, so they collect a lot of light, so that's great for fainter objects. For reasons I'm not going to go into, Maksutov telescopes tend to be rather smaller apertures. Mainly they get too expensive if the aperture gets large, and the same is true for refractors. You don't end up with very large aperture refractors because they're just too expensive. And it's cheaper to make large aperture with mirrors, as indicated by these three types of telescope. And if you want the best bang for your buck, if you want the largest aperture for a given cost, that's widely accepted to be the Dobsonian design, gives you the largest physical aperture for the smallest outlay of cash. The three on the left there have sealed optics, which means that there's some optical element at the front as well as the back, whether that be a lens or a corrector plate, for instance. That means it minimizes the ingress of spiders and small furry creatures that might want to take up a nest in your telescope if you have the front element open. Usually when you store it, you cover everything to make sure there isn't, but somehow these small animals find their way into your telescope. So generally speaking, these three on the left might be lower maintenance than the two on the right. And if you're going to be moving your telescope around, if you want it to be transportable, then you have to think about how big, how heavy, physically how big or physically how heavy is this telescope. Newtonians can be quite large, Schmidt-Cassegrains can be quite large and quite heavy. So the best ones for portability are the Dobsonians. They are physically quite large, but they are designed to split so the tube and the mount can be separated and relatively easily put into the back of a car. Refractors tend to be smaller, and the Maksutov design gives you, for a given aperture, gives you a long focal length in a very short tube. So portability is quite high for those instruments. To give you an idea of what you might expect to pay, this particular set of numbers was compiled a couple of years ago, but last time I checked, they hadn't actually changed that much. I think telescope prices went up a bit a couple of years ago, and they've sort of plateaued. So even though these prices are slightly out of date, I think they're still valid. It gives you an idea of how much you might expect to pay. For instance, for a refractor type of telescope, how much might you expect to pay for a 3-inch or a 4-inch or a 5-inch aperture? It's just easier to make this with inches rather than millimeters. I'm sure you can all do the conversion if you need to. And perhaps you can already see that you get more bangs for your buck because a Dobsonian of a given size is going to be cheaper than a refractor of a given size, and similarly for the other telescopes. So I'm not going to tell you how much to pay for a telescope, but if you've got less than £100, most people would say, well, you're much better off thinking about binoculars on the left-hand side there if you're talking about having a few tens of pounds, with the exception that if you're buying for a youngster, maybe you could buy them a telescope for 50 quid or something like that. But which would be the best telescope? Well, I've read a number of guides which say this is the top 10 telescopes for anybody beginning in astronomy. Some of them say you ought to be thinking about a 5-inch Newtonian telescope. Well, that indeed is not a bad telescope. Different guides might say you really ought to go for a Dobsonian because then you get the largest aperture for a given amount of cash. Well, I guess that's true, but I would argue pretty much anything in the blue rectangle is probably a fairly good start for anybody thinking of buying their first telescope. Obviously, quality matters, and generally speaking, you will get higher quality telescopes if you push towards the £500 end of the range rather than the 100, but I don't think you can go too far wrong if you pick a telescope somewhere in that blue rectangle. I read the Sky at Night magazine, which said, if you want a starting telescope, the one you ought to go with is an 8-inch Newtonian. Well, I'm sure that's a superb telescope, but it's £700. That's not what I would call a starter telescope. So perhaps you ought to be thinking about something a little bit further down, and perhaps you'll work your way up to one of those in due course. One thing to bear in mind is down here, perhaps you've noticed that Schmidt-Cassegrain has got a large blank area because nothing happens until at least £500. And even there, OTA means optical tube assembly. In other words, that's only the telescope, not the mount onto which you have to put the telescope. If you want a complete telescope, you basically have to pay £700 or more. The reasons there's little pointy arrows on the right is that this is not the end of the graph. The graph goes on almost to infinity. You can pay as much as you like for any of these telescopes. This is only thinking about what you might start off with. But remember, regardless of whether you decide to go for a telescope or not, if you are interested in astrophotography, you can make yourself a star tracker for, I don't know, 20 quid or so, depending on what you happen to have lying around in your workshop. I've got some flyers here to tell you how I built a tracker for myself. You can buy clockwork trackers, which literally are just wind up, put them down, they will then move the camera at 1 revolution a day to follow the stars. If you wish, you can buy motorized trackers for a couple of hundred, 200 to 300 pounds. If you are serious about astrophotography and you want to put one of these telescopes on the best possible mount that will allow you to accurately follow the sky, then you need to think about a relatively beefy equatorial mount. Motorized ones would start at £300, but perhaps the best ones for astrophotography would be further up here at about £500. And those are the ones that come with a computer and a database whereby you can say, I want a picture of the Rosette Nebula, and it will zoom off and point at the Rosette Nebula, for instance. So those prices, I think, are still good, and I've got a few copies of this if anybody wants to take this as a sort of ready reckoner guide to telling whether or not you're getting a bargain or whether you're being ripped off when you see a telescope of a given size being advertised for a given price. So let me finish with some hints and tips. I believe you can't go far wrong if you stick with a known, reputable manufacturer. This is the big five, if you like. Within the UK, most telescopes that are sold fall into one of these 5 brands. If you stick with those, you shouldn't go far wrong. I don't think any of these manufacturers make rubbish. So if you can find yourself one of these telescopes at a price that you like, you probably will be okay. If you go off-piste and start buying from somebody else, well, there's no guarantee you're not buying a turkey. So you might want to stick with the good, reliable big 5 of brands within the UK. When you're thinking about the aperture that determines how much light comes into the telescope versus the focal length, effectively how long the telescope is, remember it's aperture that will determine how faint an object you can see. Focal length is really only important if you're trying to get the highest magnification of something really tiny, like a very distant planet or something like that. Most of the time, most people would say it's more important to get the largest aperture you can afford to make sure you're collecting as much light as possible. In principle, that will get you to the faintest objects and will give you the most detail. Focal length will determine the magnification of what you see in the eyepiece, but that's often less important than you think. Your telescope may or may not come with a few eyepieces. Generally, they come with 1 or 2 eyepieces. and usually they are chosen to be appropriate magnification, in the middle range of magnification. I would suggest that you buy a telescope, you get whatever eyepieces you're given, and once you've used the telescope for a while, you'd then be in a position to decide, I would like a lower magnification, I would like a higher magnification, and then you might choose to buy other eyepieces which give you different magnification. But given that magnification is not really as important as you might think, that's a decision that I think you ought to leave until after you've purchased a telescope. But one thing you do have to think about is ergonomics. It's not just about optical quality, it's not just about aperture and focal length. You have to ask yourself, where are you going to be using this telescope? Is it going to live indoors and you're going to take it outdoors whenever you want to use it? Is it going to live in a shed? Is it going to be taken to a dark sky site? Are you going to use it on a tripod? Is it so small that you're going to have to use it on a table if you haven't got a nice sturdy tripod? Are you going to have to be taking it to a dark sky site because you live in a suburban area which is thoroughly light polluted? Does it have to be transportable? Is it something you can just tuck under your arm, or are you going to need a Pantechnicon to take it anywhere you want to go? And I've already given you a hint that astrophotography changes everything, in the sense that if you're not worried about astrophotography, you go with the telescope of sufficient optical quality and the right size for you. If you're thinking of, you definitely want to buy a telescope with astrophotography in mind, then you have to worry about the fact that the precision of the mount that you want to put it on has to be so much higher. If all you want to do is to keep Saturn in the field of view as you watch it, that doesn't require high precision. If you want to take a picture of a very distant galaxy and you want that camera and telescope combination to track very accurately, you will need a more expensive, more precise, probably heavier mount. And that's something that you have to bear in mind when you're thinking of your first purchase. Go-to telescopes, well, people are divided about that. Is it good to have a telescope which is so intelligent it can figure out which objects you want to look at? Or do you want to be in control of what it is you're doing? Go-to telescopes are generally more expensive. They can be good for finding an object if you don't know where it is. But astronomy is supposed to be a hobby. Don't you want to learn your way around the night sky? Well, maybe you don't, but just bear in mind that if you have a go-to telescope, it will stop you learning your way around the night sky. Because if you've got the go-to facility, you will use it, and you will say, give me the Rosette Nebula, even if you've got no idea where the Rosette Nebula is in the sky, for instance. If possible, try before you buy. It's not always possible. But if you could, for instance, go along to an observing evening and look through other people's telescopes, preferably at the same object, what does this telescope give me for a view of Saturn? What does this telescope give me for a view of the same object? And then you can judge, well, that one's more expensive than that one, but I think that's worth the money because I like the way that particular telescope works, or I like what I see through that telescope. And of course, there's always the option of buying second-hand, but be careful. You can get stung this way. If you see something that looks like it's an absolute bargain on the internet, talk to somebody else first. Don't go ahead and buy it without checking with somebody else who has the experience to know whether or not it is a bargain or not. Try and avoid adding everything to your telescope. You might want to buy a telescope and then think, well, he's got a nice telescope. He's added another telescope on the side and then a guide scope, and now he's doing wide field as well as long focal length. Well, you can if you like, but it gets more and more and more expensive. And some people seem to want to keep adding accessories to their telescope until they run out of cables. So, I mean, you can if you like, but I would suggest you try and avoid going down that particular rabbit hole. Watch out for the fact that sometimes in catalogues and sometimes on the internet, you see comparisons of telescopes and you think, well, that one's cheaper than that one. Maybe the one on the left would be better. And then you don't realize, perhaps until you look closely, that they're not shown on the same scale. That's the actual relative size of those two telescopes. And if you ask yourself how you want to use that telescope, you realize that perhaps this one is really not suited to you, perhaps. So now you see why the one on the right is more expensive than the one on the left. And if it's bigger, well, bigger is often better in terms of aperture, but bigger means heavier. There's no point in having a fantastic telescope if you can't lift it into the back of the car or you can't lift it out of your house into the back garden. That telescope is not going to be used. So bear in mind what the weight is of these things if you're going to have to lug it around rather than perhaps get your spouse to lug it around. Read the specification. Perhaps that's obvious. I don't think anybody has fallen into this crap. But make sure you know what you're actually getting. What you don't want to do is to order a telescope and have it turn out and realize that it looks fantastic, but actually it's a lot bigger than I thought it was. The photo was a little bit misleading. And yes, that Meade telescope is 300 kilograms. Yep. So it does sound very heavy, but don't worry. Meade have taken that into account, and they will ensure that if you do buy this telescope, your bank balance is going to be a lot lighter to compensate for the fact that telescope is 300 kilograms. So your options are many and varied, which is good and bad and confusing because you have so many options. I would estimate you could choose one of maybe 1,000 different telescopes, certainly many hundreds, possibly as many as 1,000 different types and makes and variations of telescope within the UK. So try not to suffer if you're trying to make this decision. Try not to suffer from analysis paralysis. In other words, look at what you can afford, take advice, and make a decision and go away and enjoy your stargazing. Most of all, make full use of the resources of your astronomical society, by which I mean, of course, the members. The best telescope, some people would say there's no such thing as the best telescope. Other people would say, absolutely there is. It's the one you use. Thank you very much for listening to my rough guide.